Hello everyone, I'm Lewen, a recent student in Zhang's group. In the last video, Jingyi walked us through a full transition state discovery workflows using CHEMSMART and Gaussians, from PS optimizations and IRC to the final single point energy calculations. So in this video, we will continue with the same SN2 reactions as our working example, and I will show you some of the more advanced Gaussian workflows available in CHEMSMART. We will cover 3 parts. In part 1, I will show you 3 ways to run a coordinate scan job using scan, com, and user job, and introduce some commonly used options for customizing your Gaussian input on the fly. And in part 2, I will cover how to process multi-structure XYZ files, especially crest conformal ensamples and trajectory files, and batch submit Gaussian jobs for all of them at once. And in part 3, I will go through electronic structure analysis and property calculations, including the NCI, WBI, DIS, TD-DFT, and RESP. So alright, let's get started. Before searching a transition state, it's often useful to first scan along a key coordinate, like a forming or breaking bond, to get a rough picture of the energy surface and identify a good TS gas. So let's start with how to set up a scan job in CHEMSMART. There are 4 flags you need to know for the scan command. /C is where you tell CHEMSMART which coordinate to scan. /S and /N set the step size and number of steps. And /CC is for any additional constraints you want to freeze during the scan. Here, I have the randomly built starting structure for our SN2 reactions, where the fluoride anion is attacking the methyl chloride. Let's say I want to use this structure to find a good TS gas. To do that, I will scan along one of the 2 key coordinates, either the distance between atom 1 and atom 2, which is the forming carbon-fluorine bond, or between atom 1 and atom 3, the breaking carbon-chlorine bonds, and see how the energy changes along the way. Let's start by scanning the carbon-fluorine bonds. That's the distance between atom 2 and atom 1. I will use a step size of 0.1 angstroms and take 20 steps. Once the job is done, we can open the upper file in Gaussian to check the scan results. Here, you can see how the energy changes as we scan along the carbon-fluoride bond's length. The curve gives us a clear picture of the energy profiles, and we can pick a suitable point as our TS initial gas. Of course, in some cases, you may want to scan along multiple coordinates at the same time. CHEMSMART supports that too. Here, I'm scanning both the carbon chloride bonds and the carbon fluoride bonds simultaneously. And once the job is done, we get a nice 2D potential energy surface in Gaussian. One thing to keep in mind, the step size and number of steps are matched to each coordinate in order. So the first values go with the first coordinates, and the second with the second. And you are not limited to bonds either. You can pass free atom indices to scan an angle, or fall for a dihedral. CHEMSMART also supports scan jobs with additional frozen coordinates. Using the /CC flag, you can specify bonds, angles, or dihedrals that should remain fixed throughout the scan. Here are the 3 Gaussian input files generated by CHEMSMART for each of the 3 scan types we just covered. Here comes the questions. What if I already have an existing input file, or I want to customize the calculation task? CHEMSMART has 2 ways to handle this. With the com functions, you can directly submit a Gaussian input files that you already prepared for yourself. And with user job functions, you can define a fully custom calculation from scratch. If you already have a prepared input file, all you need to do is use the com command to submit it. Now for the user job. It has 2 main options. /R is where you define the row sections of the Gaussian inputs, is where you specify the job type, method, basis set, and so on. /A lets you append additional information to the end of the input file, which is useful if your job needs extra sections. Here's an example where I use user_job to set up a scan job. And here's the corresponding input file generated by CHEMSMART. Beyond scan, com, and user_job, there are also some commonly used options that work across CHEMSMART Gaussian commands, letting you further customize your job from the command line. /O add extra optimization options, for example, max steps. /R appends additional road parameters, so you can include extra keywords in the road section. /A appends additional information to the end of the input file. And /D controls the DS tag, which sets Gaussian output verbosity. Now let's move on to part 2, processing multi-structure XYZ files. Sometimes you have not just one structure, but a whole set of them. For example, a conformal ensemble from CREST or a series of structures along a reaction trajectory. CHEMSMART let you batch submit Gaussian jobs for all of them at once, using the CREST and traj commands. Here's the help info for the CREST command. Here I have a multi-structure XYZ file from a CREST conformal sampling run. I can take the top 10 lowest energy conformers and run a geometry optimizations on each of them in a single command. And here are the results. And similarly, here's the help info for the traj commands. The traj command works similarly. Here I have a trajectory XYZ files, and I want to run an optimizations on the last 5% of structures. And here are the results. Now for the last part, electronic structure properties and analysis. Once you have a well-optimized structure, you often want to go beyond the energy and look at things like bonding, reactivity, or excited states. CHEMSMART provides a set of commands for this: DIAS, NCI, WBI, RESP, and TD. Let's start with the DIAS, the distortion interaction activation string analysis. It decomposes the activation energy into two components: the distortion energies, which is the energy cost of deforming each reactance into its TS geometry, and the interaction energy between them. CHEMSMART DIS function automates the single point calculations needed to get the distortion energies of both fragments. Here's the help info for the DIS. /I is where you specify the atom indices of one of the two fragments. CHEMSMART will treat the rest as the other fragment. /N lets you run the analysis on every nth point along an IRC path. /S turns solvent on or off for the calculations. /M sets the modes, either IRC to run the analysis along the full IRC path, or TS to run it on just the TS structure. And other options let you set the charge and multiplicity for each fragment separately. Here, I have an IRC path going from the reactant to the transition state. I want to define atom 2 as one fragment and treat all the remaining atoms as the other fragment. I use /n3 to sample every third point along the IRC and /m_IRC to run the full IRC-based analysis. Here are all the output files CHEMSMART generated. If you also want the equilibrium energies of the two fragments, you can take the fragment input files and run your own optimizations and single point calculations on them. Next is NCI, non-covalent interaction analysis, It visualizes non-covalent interactions in the molecules. To run it, just append NCI to the command. The generated wave function file can be then passed to CHEMSMART NCI plot and generate two cube files, one for the RDGs and one for the sign of the second eigenvalue times the electron density. Finally, you use CHEMSMART mode functions to package everything into a PSC files, which you can open directly in PyMode to visualize the NCI isosurfaces. Next is WBI, Weber bond instance analysis. It gives you the quantitative measures of bond order of each pair of atoms. Running WBI in CHEMSMART is straightforward too. Now for TD, time-dependent DFT, it used to calculate excited state properties, such as UV absorption spectra and vertical excitation energies. If you are working with molecules that absorb light or have photochemical relevance, this is the calculations you want. And the last one is RESP, Restraint Electrostatic Potential Charge Fitting. CHEMSMART handle this with a fixed road, so you don't need to set up the road sections yourself. The one thing you do need to specify is the output file names for the ESP data, using the /A flag on the command line. That's everything for this video. We have covered a range of Gaussian workflows in CHEMSMART, from setting up scan jobs and customizing inputs, to batch processing multi-structure files, to running electronic structures analysis and property calculations. Hopefully, this gives you a clearer picture of what CHEMSMART can do beyond the basics. Thanks for watching.